This is a medium difficulty problem related to movements or rotation. We will solve using torque method. Let me give you the gist of the problem. We have a beam shown in yellow, balanced by two wedges shown in blue. On the left edge, there is a weight placed. We need to find the weight exerted by the beam on each of the wedges. To solve this problem, we draw forces that are shown in red. There are four forces in play. Two of them are downwards by the weight of the beam and weight of the mass. Two are opposing forces, which are normal forces from the wedges. We call NL and NR. So we need to determine what is NL and what is NR. Let us work for the solution. You will note that the system is static or there is no rotation about any point. If there is no rotation, the net torque is zero. The torque is also given by R cross F, which is RF sine theta. Here all the angles from the forces will be 90 degrees, so sine of 90 is 1. As a first step, we will find the torque about A. There are three forces from which the torque needs to be calculated, which are from B, C, and D. There will not be any contribution from the force at A because the distance is 0. We calculate the torque about A from the force at B. To do that, we draw the position vector, we draw the force so that they start from the same point. As the torque is represented by R cross F, we go from R to F, which is counterclockwise, so it comes out of the page, and so it is positive. And the torque is given by L3, L divided by 3 times NL. Now we do the same for the force at B. Position vector, force starting from same point. To go from R to F, it is clockwise, therefore into the page, therefore negative. And this is the torque given in the circle. We do the same for the force at D. Position vector, force vector, going from R to F is counterclockwise, so it is out of the page and positive. And this is the torque due to the force at D. Now we sum up all these torques, which has to contribute to 0. And this is the final answer that we get, shown in red. Try to see if you get the same answer. In this new slide, we show the equation we got from the previous slide. And now we will calculate the torque about D. There are three forces that we need to consider, which is at A, B, and C. There will not be any contribution from the force at D. So let us calculate. Here is the torque calculation from the force at A. And now for the torque from the force at B. And now from the torque from the force at C. Now we add them up, which should be 0 because the system is static and there is no net torque. I hope you have got the solution. At this point, all the physics is done. We have two equations and two variables to calculate, which are NL and NR. This is also called simultaneous equations, and we will solve using Wolfram Alpha. This is the screenshot of Wolfram Alpha. It is a free tool. The URL and the command that is needed to be written is given in the last line shown in purple. We also provide command text in the video description so you can cut and paste. You can see the result that we need. On the right is the answer that we have got from Wolfram Alpha, which is the final answer. Now we need to do some validations just to check whether we are right or wrong. And as a part of first validation, we can see that if we add NL plus NR, that is equal to the total weight. And this is what we expect, because normal force is the response to the total weight exerted on them. So that is correct. Let us see for the second validation. If the mass was 0, we will have a symmetry left and right on the line that passes through C. So NL and NR must be equal and share half of the weight. And this is exactly what we get. Very good so far. However, you may have noticed that if we had chosen the point B to calculate the torque instead of point A, the equation could have been very simple. So why don't you try it and get the same answer? In this final slide, let us summarize. On the left side, we show the final answer. You may also have some lingering questions, such as, how do I use Wolfram Alpha? Or, how do we calculate the torque from a force? We took R, we took F, drew from the same point, went from R to F, which in this case is counterclockwise, which is into the page, and therefore it is negative. What is going on? For this, we will create video separately and post the link in the description. That is all for now. Bye bye.